Today we will be talking about asymptotes, and there is three types of asymptotes that we care about. There is the vertical asymptote, there is a horizontal asymptote, and there is a oblique asymptote. We won't be covering oblique asymptote in that video, we will be only covering vertical and horizontal. Vertical means whenever we have x equal to a certain number, and horizontal asymptote means y equal to a certain number. Now, to understand what does a vertical and horizontal asymptote mean, let's say we had a vertical asymptote at x equal to 1, vertical asymptote at x equal to 1, and a horizontal asymptote at y equal to 2, let's say. Let's draw them first. X equal to 1 is here, so this is our vertical asymptote, and our horizontal asymptote is at y equal to 2, which is here. What does an asymptote mean? An asymptote means our functions will come close to it but not touch it or exceed it. So for example, let's say we had a function that will be in this part here. Our function will be coming next to the vertical asymptote but not touching it, and next to the horizontal asymptote without touching it. The same thing will be, for example, from that side here, where it will be coming close to our asymptote but not eventually touching it. That's the part of the asymptotes. Now, let's take, for instance, an example. Let's say we had f of x is x minus 1 over x plus 2. First things first, we need to check our domain. To see what the domain of our function is, we need x plus 2 to not be equal to 0, because always the denominator cannot be equal to 0. So x cannot be negative 2. This is our condition, which means our domain will be from negative infinity to negative 2 excluded, union negative 2 to infinity. Or you can write it as set of R minus element 2. This is our domain. Now, we'll need to check if we have any asymptote on this condition. Then we'll need to do limit as x tends to negative 2 from the negative side of the function, and limit as x tends to negative 2 plus of the function. If we get infinity or negative infinity, it means we have an asymptote, a vertical asymptote. So we have limit as x tends to negative 2 minus of x minus 1 over x plus 2. Replacing minus 2 minus, we'll have minus 2 minus 1 over minus 2 minus plus 2. Minus 2 minus 1 is minus 3 over minus 2 minus plus 2, which means we'll have 0 minus, because we have the negative sign. Now negative over negative will become a positive, which means 3 over 0 plus, and any number over 0 is infinity. Now we'll do the same for negative 2 plus, where we'll have limit as x tends to minus 2 plus of x minus 1 over x plus 2. And now we replace, we'll get negative 2 plus minus 1 over negative 2 plus 2. Negative 2 minus 1 is negative 3. Negative 2 plus 2 will become 0 plus, because we have a positive here. And negative 3 over 0 will become negative infinity. Since we have values at infinity and negative infinity, that means we have a vertical asymptote at x equal to 2. And how will this asymptote be? We have, this is our graph, and this is x equal to 2. From the negative side, from the left side of x equal to 2, we have the function going to infinity, which means we have our function approximately here. And from the left, from the right side, which is negative 2 plus, it's coming from negative infinity. So our function will be something like that. Okay, now let's see if we have any horizontal asymptote. To find any horizontal asymptote, we find the limit as x tends to infinity of our function. So x tends to infinity of our function and negative infinity. Now, our function is x minus 1 over x plus 2. You need to find limit as x tends to negative infinity of it and limit as x tends to infinity. I have a previous video where I explained how to find limits as x tends to infinity, where we can directly take the highest x power with their coefficients. So we have limit as x tends to negative infinity of x over x, where x and x can cancel out, where we'll be left with 1. The same thing here, limit as x tends to infinity of x over x, where x's will cancel out and we'll be left with 1. You see, we have ones, which means we have a horizontal asymptote indeed. And the horizontal asymptote here is y equal to 1. This will be a horizontal asymptote. What does a horizontal asymptote mean? It means whenever our function is approaching infinity, our y value will be approaching 1. So as you can see here, let's go back to the graph that we had. We have y equal to 1, which means approximately here. This is our y equal to 1, and that is catching, of course. We need more accurate value to make a better graph. As it goes to infinity, our function is approaching 1 from here and from here. So this is a sketch of the function x minus 1 over x plus 2.